What is the most expensive object in the universe? You might think it's a flawless diamond or a lost masterpiece of art worth hundreds of millions. Perhaps it's the pinnacle of our technology, orbiting high above the Earth. But all of these are worthless trinkets, cheap toys, compared to the real thing. The most valuable substance known to humanity is not found in a mine or an auction house. It is forged in the heart of colossal machines that recreate the birth of the universe. It is the mirror image of our reality, a perfect reflection with a terrifying power. This is antimatter. And the story of why it's worth more than all the treasures on Earth combined will change the way you see the world. If you're ready for the truth, subscribe now. The journey begins. The story of the universe's most valuable object doesn't begin with explorers or kings. It begins here, in the strange, beautiful, and uncompromising world of a mathematical equation. A world of perfect symmetry where every positive has a negative, and every particle must have an antiparticle. In 1928, a brilliant and eccentric young physicist named Paul Dirac was trying to unite the two great ideas of his time: Einstein's relativity and the new, bizarre world of quantum mechanics. But his equations produced a ghost, a strange, nonsensical solution that suggested the existence of an electron with a positive charge, a mirror image of our world. His theory was radical. It predicted that if this anti-electron ever met a normal electron, they would annihilate each other in a perfect, clean burst of pure energy. The scientific community was deeply skeptical. It sounded more like science fiction than physics, a shadow universe made of antimatter. It was absurd. For years, Dirac's ghost remained just that, a theoretical curiosity, a strange quirk in an equation with no proof in the real world. But across the ocean, at Caltech, another scientist named Carl Anderson was studying cosmic rays, the high-energy particles that rain down on Earth from space. And one day, inside his cloud chamber, he saw it, a ghost, a particle that behaved exactly like an electron. But when placed in a magnetic field, it curved the wrong way. It was the unmistakable signature of a positive charge. It was Dirac's anti-electron, the first piece of antimatter ever discovered. He called it the positron. The news was a bombshell. The ghost in the equation was real. Dirac was no longer a radical theorist. He was a prophet. He had seen the reflection of our universe, written in the pure language of mathematics, before anyone had ever witnessed it with their own eyes. Knowing antimatter existed was one thing, but to truly understand it, to harness its power, humanity had to do something that sounded impossible. We had to make it. The first attempts were like trying to forge a single atom with a sledgehammer. In giant room-sized particle accelerators, scientists began smashing matter together with incredible force. The principle was born from Einstein's famous equation: E equals mc. Energy can become mass by accelerating particles to nearly the speed of light. Their collisions would create a flash of pure energy, hot enough to mimic the birth of the universe. And for a fleeting trillionth of a second, a few precious particles of antimatter would spark into existence. But this created the ultimate paradox. The universe is made of matter. The moment an antiparticle is born, it is surrounded by its mortal enemy. Annihilation is instant. How do you hold something that is destroyed by the very act of touching it? How do you build a container when the container itself is made of the substance that will destroy your creation? The solution was as elegant as it was brilliant: a magnetic bottle. Using powerful, intricate magnetic fields, scientists created a trap. A perfect vacuum where antimatter could be suspended, held in place, never touching the walls of our world. And for the first time, we could hold it. A tiny glowing cloud of positrons, the first piece of the anti-world, created and contained by human ingenuity. But the cost, the sheer energy required for this feat, was astronomical. To create a single gram, we would need to run all the power plants on Earth for centuries. This is the source of its immense value. To push the frontier, humanity built modern-day cathedrals of science. Places like CERN, home to the most powerful machines ever created. Inside the Large Hadron Collider, the process was refined and scaled up. More energy, more collisions, creating not just simple antiparticles, but the building blocks of an anti-atomic world. And then came the breakthrough that opened the door to the future, the creation and trapping of the first complete atoms of antihydrogen. A stable piece of another universe held captive in a laboratory on Earth. We had done it. We had made the impossible. So why do we spend billions of dollars and decades of effort to create mere atoms of this substance? The answer lies in one perfect, terrifying reaction: matter-antimatter annihilation. The only process known to humanity that converts 100% of mass directly into pure energy. It is the universe's perfect engine. A chemical rocket is a firecracker. A nuclear bomb is a cannon. But antimatter is the thunder of the gods. With this perfect fuel, a new era of exploration becomes possible. An antimatter engine could power a starship, allowing us to travel to the nearest stars, not in millennia, but in a single human lifetime. It is the key to interstellar travel. But its power is not just for the cosmos. In the quiet world of medicine, antimatter is already being used in PET scans, allowing us to see inside the human brain and detect disease. But its greatest scientific value is in helping us answer the most profound question of all. In the beginning, the universe should have created equal amounts of matter and antimatter. They should have annihilated each other completely, leaving behind a universe of nothing but light. So why are we here? Why did matter survive? This imbalance, this cosmic flaw, is the reason we exist. By studying antimatter in our labs, we hope to understand the secret of our own creation. But with this godlike power comes a terrifying, world-ending potential. The destructive force of a single gram of antimatter would make a nuclear weapon look like a child's toy. It represents not just the price of innovation, but the potential cost of our own ambition. In the very first moment of creation, the universe was born in perfect balance. For every particle of matter, an equal and opposite particle of antimatter was forged. A perfect, beautiful mirror. But this perfect symmetry was a death sentence. Their destiny was to annihilate each other, leaving behind a cold, empty universe of pure light. But something impossible happened, a tiny flaw in the mirror. For every billion annihilations, a single, lonely particle of matter survived. Our entire universe, every star, every planet, every living being, is a leftover, a cosmic rounding error. The beautiful, chaotic debris of a perfect war. And now, inside our modern cathedrals of science, we have built machines that allow us to echo that first moment of creation. We are no longer just children of the universe, looking up at the stars. We are becoming its architects, learning to write the fundamental equations of existence itself. In our hands, we now hold the power of creation and annihilation, the fire of the gods captured in a magnetic bottle. We have spent centuries reaching for this ultimate power. But the question is not, can we wield it? The question is, should we? When we look out from our fragile blue marble into the vast, silent void, we see a reflection of our own journey. A tiny civilization born from a cosmic accident now holds the power to create and destroy realities. And perhaps that is the final truth. The most expensive object is not a substance we can own. It is a question we must forever ask ourselves. It is the price of our own ambition, the mirror of our own genius. A final and profound echo of genius.